Hey there and welcome. This video is going to talk about how to determine the domain and the range of a function. We are on page 33 of your Algebra 1, Quarter 1 notebook. So in our last lesson, we talked about what is a function, what is a relation, how do I determine if a relation is a function or not a function. We also discussed that x can also be called the domain. So values of x are often called the domain, and values of y can also be called the range. And that's what we're really going to focus on in this video. What are the x values of a relation or a function? And what are the y values of a relation or function? So we had talked about the fact that this was a function because there were no repeating x values. And what are the domain and range? Well, as I noted, the domain are the values of x. So let's take a look at the values of x, 1, 2, 3, and 4. So I'm going to write it like this, domain, colon, 1, 2, 3, and 4. So I have just determined the domain of this function. For the range, I'm looking at the values of y. I have 4, 8, 12, and 16. So the range will be listed as 4, 8, 12, and 16. I want you to note that as I listed my domain, I listed it in numerical order from least to greatest. My range is listed similarly in numerical order, least to greatest. In number 2, in this mapping diagram, we determined this was not a function. We determined this because I have 2 points where I have 2, 6, and 2, 7. So there are repeating x's, not a function. But I can still list my domain and range. The domain is going to be 1, 2, 3. Now you might say, but 2 goes with 6 and 2 goes with 7. Well, that is true, but when I'm stating domain and range, I do not state repeats. For my range, I can see that I have the numbers 5, 6, 7, and 8. Okay, the final relation, we determined in our last class that it was a function because I have 3 different x's, 0, 1, and 2. Repeating y's, 5, 5, and 5, are absolutely okay when determining if it's a function or not a function. It's the repeating x's. So let's look at the domain. Again, I have 0, 1, and 2, and that is in numerical order, except I almost wrote the 2 first. Oops. 0, 1, and 2. The range is 5, 5, and 5, but I'm not going to write the repeats. I'm just going to write 1, 5, and that is my range. So now we're going to move to page 35, and we are going to determine the domain and range of each relation. Now, in our last class, we also looked at whether or not these relations were functions. We determined that this set of ordered pairs was a function because if I go for the vertical line test, there is no vertical line that has 2 points on it. Now, I'm so sorry that this graph is not amazing, but if I get a set of ordered pairs, we're going to work with it the best we can. The best way to find your domain and range is to find the ordered pairs. I'm going to start at this bottom left corner and move up, if I can, diagonally, to try and get that in numerical order. So here I am at this point, and to find my x value, I go -1, -2. To find my y value, -1, -2, I go down 2. Okay, my next point is right here, and I'm going to go -1 for x, -1 for y. My third point is right here at the origin. And just to note, if this were on a test, the graph would look a lot better because these and fifth points aren't very hard to figure out, but I do know I go over 1 for x. Now it could be 2 or 3. We'll say it's 3. Over 1, up 1, 2, 3. And my last point is going to be over, 1, 2, 3, 3, and up 3. So I'm going to write my domain by listing my x values in numerical order, -2, -1, 0, 1, 3, already in numerical order. And I'm going to list my y values in numerical order, but I'm not going to write the repeat. So I will do -2, -1, 0, and 3. Alrighty. So when I'm listing mapping diagrams, ordered pairs, I'm listing the values of x for my domain and the values of y for my range. Graphs are a little bit different. What I'm really looking for graphs are, I've got to extend my thinking to think this is the coordinate plane. And it's not just this box. Really, the coordinate plane represents a never-ending plane that goes forever in all directions. So I've got to kind of expand my thinking to find the domain and range for things that are just not ordered pairs. Here I have this line. And if I think about domain, I'm going from my left to the right. And I want to imagine if this line extends forever this way, it will eventually hit negative infinity. It's going forever slightly to the left, and eventually it's going to hit negative infinity. Likewise, as it goes slightly upwards, it's also going right to infinity. When I go from negative infinity to infinity, I am in the situation where x can be this symbol, which stands for all real numbers. And what that tells me is that any value of x works for this particular function. And I write it this way, and this is where it's a little fancy math. I have x, and I'm going to use this line to indicate x such that x is a member of the group all real numbers. That's the most easy way I can translate it. So this is the symbol for all real numbers. This says it's just part of that group. When I'm thinking about range, I need to think about up and down. That's going to be my range. So think about this line. It's going down forever. Eventually, it's going to hit negative infinity, which of course is never ends, right? And if you go up, you're going all the way to infinity. So if I'm going from negative infinity to infinity, it is all real numbers. So this line also has a range of all real numbers. This next one, number 10, you're looking at an absolute value function. And I'm going to do everything the same way. I'm going to look at the domain, left to right. And I have to imagine as this line is slightly curved, it's going out along the x-axis all the way. It's going to keep on going forever to negative infinity. And this arrow going slightly up to the right is eventually going to hit infinity. So again, with these types of functions, I am domain going to have all real numbers. The range, though, is different because if I look up and down, I can see that it's going to go up to infinity, right? It's going up forever, but it does not go down forever. And in fact, it stops here at -1, -2. So because it's going up from -2, my y values are getting bigger. When I go up, my y values increase. So y has to be greater than or equal to -2. All of my y values will be -2 or more. So my range is y so that y is greater than or equal to -2. It goes on forever because any number, even infinity, is greater than -2. But it's not the all real number system because it does not get smaller than -2. This was not a function. Look here. This vertical line hits that graph on 2 points, so not a function. I called it a sideways parabola. So let's look at our domain, my left to right. You can see that it's going left to -infinity, right? But if you go to the right, it stops. And now we're on the horizontal line at 1, 2, 3, 4. It stops right there at number 4. So it gets going to the left, it gets smaller, it decreases. So x has got to be less than or equal to 4. It can be 4, but it's going to be less than 4. It's never going to be bigger. So my domain is x, so that x is less than or equal to 4. The range, and this is really, really hard to visualize. This is going out ever so slightly. The subtle nature of the increasing. This is going to go ever so slightly. It's going to go a lot more slowly to -infinity, up and down. And it's going to go a lot more slowly up to infinity, but it is going to get there. This is in all real numbers for my range. So I get to write my nice funky symbols, the little curvy E and the double-lined R. Alrighty, we're going to do one more. We are not going to do 13 in this lesson because we are not going to cover compound inequalities in Algebra 1. But we are going to cover horizontal lines. And what I have is a horizontal line right here. And when I think about left to right, if I'm going left, eventually I'm going to get to -infinity. If I'm going right, I'm eventually going to get to infinity, which of course is never again. So it's all real numbers for my domain. My range, however, is a little different. This is the line. It's at the same number every time. If x equals 0, y is 1, 2, 3, right? If x equals 1, 2, y is at 3. If x equals -2, y is at 3. If x equals 1, 2, 3, 4, 5, y is at 3. If it equals -5, it's at 3. And in fact, I could keep on going down the line. Y equals 3 all the time. That is the range of this particular function. It is y equals 3 because there is literally no other value for y in this horizontal line. So hope you enjoyed the notes. We are going to practice identifying domain and range. And that's it for this video. See you next time.